Welcome to another Night Sky News, everybody. There is far too much to talk about to waste time on introduction, so let's get straight into it with what you can see in the night sky in this coming month. So on the 23rd and 24th of May, my usual favourite thing to see in the sky, a toenail moon with Venus, but this month Mercury as well. This is going to be a lot easier to spot on the 24th though, rather than the 23rd, because on the 23rd the moon's going to be the barest sliver of a crescent near Venus and also very close to the horizon. So on the 24th, be a little bit bigger, and also it'll have risen a little bit higher as well. So you can use the moon to then find Venus, which will be incredibly bright. You shouldn't be able to miss it. And then once you're there, you should be able to find Mercury from there as well, because Mercury will just be that little bit higher than Venus. And you'll need that because Mercury is so much fainter than Venus, and when it's out, the sun is still sort of lighting up the sky a little bit during twilight. So if you are in a very dark location, you have a chance of being able to see it with the naked eye, but otherwise just, crack out the binoculars and see if you can find it. Mercury will get easier to spot as the weeks go on, so by the 3rd of June, it'll hit what's called its greatest elongation, which is basically the furthest point in the sky that it will get away from the sun. It's the moment which Mercury, the sun and Earth make a nice right-angled triangle. As for Venus though, it is getting closer to the sun from Earth's perspective anyway, all the time now. So this is actually the last chance we're really going to be able to see Venus this month. By the end of the month, it will have actually set because it will be so close to the sun, you'd only be able to see it during the day, and the sun is too bright to do that. So if you love the toenail moon or the tiny crescent moon as much as I do, and Venus together, make sure you spot it on the 23rd and 24th of May. Then for the early rises, by the 12th and 13th of June, the moon, which will be just past full by that point, will be very close to Mars in the sky. It'll also be very close to Saturn and Jupiter, which will be just up and to the south of it. And it's a great time to try and use the moon to spot Mars. Mars will have that distinctive reddish tint to it. Jupiter will be incredibly bright in the south, and again Saturn close to it but not as bright. So if you're not sure what you're seeing is Saturn or Jupiter or Mars, then what you're going to need is one of those night sky apps, which is why this month's episode is actually sponsored by Redshift Sky Pro. This is a stargazing app that once it knows your location, you can point it in any direction in the sky and it will tell you what you are looking at. It's a great way to find objects like planets, comets, or even nebula, but also to make sure that what you've seen in the sky actually is what you think it is as well. It also has a red light feature to turn your phone screen red so that you don't ruin your night vision whilst you're out stargazing, which is actually one of my favorite features of the app. It's available in 10 different languages from both the Google Play and Apple app stores. And from today, Wednesday the 20th of May, until Sunday the 24th of May, they're actually having a sale. So instead of costing you £8.99, it'll only cost you £7.99 to download it. So if you like the sound of that, the link is in the description. Next up, I want to talk about something that people probably don't stop to think about very often. And this will depend on your location on planet Earth, depending on what latitude you're actually at. But for the mid-latitudes of the Northern Hemisphere anyway, as we get into the middle of June, this is when your earliest sunrises are going to be. You can see this for your specific location at websites like this. This is timeanddate.com. So you can see here for Oxford that the earliest sunrise is 4:45 on the 15th to the 18th of June. But the actual longest day is not until the 20th of June, i.e. the summer solstice. Now, the further north you are, the closer to the actual solstice your longest day will fall. But then the closer to the equator you get, the more pronounced the difference. So for example, in Honolulu, in Hawaii, in the States, the earliest sunrise there is actually late May. And then actually their latest sunsets don't come until early July. It all comes down to how we measure time and how we measure what a day is. The standard definition obviously is that a day is how long it takes for the Earth to spin on its axis. But the thing is, you need a reference point to decide at what point the full day has passed. So a good reference point to use would be midday. Now, I'm not talking about 12 p.m. during the daytime. I'm talking about the point at which the sun reaches its highest point in the sky. So in fact, the time that it takes the Earth to rotate a full 360 degrees is 23 hours and 56 minutes. But the time it takes for the sun to go back to the same position in the sky is 24 hours. Those extra 4 minutes come from playing catch up to get the Earth to rotate just that little bit further round so that the sun is in the same position at noon again. But also, this is just an average because the Earth's orbit is also not a perfect circle. It's an oval shaped. So sometimes we are further away from the sun and we're moving a little bit slower, and sometimes we're closer to the sun and moving a little bit faster. It means that the difference between two successive solar middays is about 40 seconds shorter in July and about 20 seconds longer in January. These ever so slight differences, of just a minute or so, mean that for our clocks, the earliest sunrise does come before the solstice, despite the fact that if you were truly on solar time, on the sun's time, they arrive bang on schedule. Right, enough night sky chat. Let's talk about all the cool astronomy news that's been happening this month, because not only do we have a possible unsolved mystery of fast radio bursts, but we also have some black hole news as well. So I usually start this segment off by showing a really cool image that's been taken by like a telescope or a space mission. But how about this month, we instead start with a piece of audio. So on the 9th of April, ESA's Bepi Columbo mission, which is currently on its way to Mercury, did a fly past the Earth for a gravitational boost in energy from us. Then on the 5th of May this month, ESA actually released that data, but what they've done is sonified it. So what they recorded was the vibrations detected by the accelerometer on board the spacecraft, which, when they're in their normal form, are a very low frequency. It's not audible to humans at all. But what they've done is play with the frequency so that we can actually hear it, and then also condense about an hour's worth of data into sort of a minute as well. So what you can hear there is essentially Bepi Columbo's vibrations as it moves through space. So one of the ESA scientists on this mission, who's called Carmelo Magnifico, which is a great name, I'm kind of jealous, compared it to putting your ear to a railway track and sort of listening to see if the train was coming, which is a beautiful analogy, if not a recklessly stupid one, to put your ear to a train track. Moving on from fun data sonification now, I'm getting a little bit ahead of myself here, but I figured people would want to know that this was happening before the actual fact. So, the first crewed mission of SpaceX's Dragon capsule is due to take place on May 27th. It will be taking astronauts up to the International Space Station for the first time. It's been tested, uncrewed many times, passed all the tests, and this will be the first crewed one. It marks the first time that astronauts have been launched from US soil up to the International Space Station since 2011, when the Space Shuttle program was retired. So it's been a long time coming. They've been using the Soyuz capsule in Russia for many years now, which is very old 70s tech. So they've needed something new for a long time. NASA is somehow managing to coordinate all of this despite the pandemic and the lockdown. They're all working remotely. Mission control is now their spare bedrooms and living rooms. Obviously, there are some very critical personnel still on site. There's only a very few people exempt though. And it's kind of strange to me that this kind of stuff is still happening during the pandemic. I tell you what, if I was an astronaut on board the International Space Station right now, knowing that 2 people from Earth were coming up, I want to know that they'd been quarantined and tested the hell out of before they came to my space station. Because the last thing we need after the 2 months we've all had is COVID in space. All right, on to my favorite topic now of black holes. So if you had asked me about 2 weeks ago, where is the nearest black hole to Earth? I would have said, why, it's V616 Monoceros. It's about 3,000 light years away and it's orbiting a star that's just a little bit smaller than the sun. You know, we've detected X-rays coming from it as far back as 1917. In 1994, we worked out the mass of it and found out that, you know, it was far too big to be anything but a black hole. But that no longer holds the title anymore because in comes HR 6819 in this paper by Ravinius and collaborators this month. So this is a black hole not just orbiting one star, it's orbiting two stars. It's actually in a triple system. It's about 1,100 light years away, so about 3 times closer than V616 Monoceros that I was talking about before, but this wasn't known to be a triple star system. People thought it was a double star system because you could actually see the 2 stars. And so it was included in a study of double star systems that these authors were doing with the 2.2 meter telescope at ESO's La Silla Observatory in Chile. But obviously for this system, when they observed it, they found that the orbits of these 2 stars just didn't make sense at all if there was only 2 stars there at least. There had to be a third object in that system. Now, they couldn't see a third object, but that doesn't automatically mean that it's a black hole. It could be something like a neutron star or a brown dwarf, something like that. They had to figure out was its mass. And you do that by sort of saying, okay, well, I have all of these possible 3-body systems of all these different masses together, and which one best fits what I've observed. And they found the one that best fits is if that unseen object was 4.2 times the mass of the sun, i.e. a clear black hole. Like, it couldn't have been anything else. It was too heavy to be anything else but a black hole. Now, this would have been noteworthy anyway because it was the closest black hole to Earth. I mean, I am still secretly hoping that this hypothetical Planet 9 that's supposed to exist in the solar system is actually a tiny primordial black hole that's like the size of a tennis ball, just because I want the solar system to have a pet black hole. But, you know, that hasn't been proved at all yet. So, you know, I'll keep dreaming with that one. But there's 2 reasons why this result is also very, very cool, on top of the fact that it's the closest black hole to Earth. The first one is that the stars that it's actually orbiting around are visible with the naked eye. Like most cool things in the sky though, it's visible from the southern hemisphere and not the northern hemisphere, which is so annoying. I'm just incredibly jealous of you southern hemispherians again. It's in a constellation called Telescopium, which is possibly the most boring constellation ever. It's just 2 stars joined up with a line, which is supposed to look like a telescope. But hopefully you should be able to find it, especially with a night sky app like Redshift Sky Pro again. And then you can go outside and look at these stars and know that you are currently looking at a black hole. The second reason that this result is really, really cool is because we don't tend to find black holes like this. Black holes that we can't actually see, and we've only just inferred that they're because of the orbits of the stars. That might sound a bit weird because, you know, the definition of a black hole is something we can't get light from at all. But the majority of black holes that we know about, including V616 Monoceros that I talked about at the beginning, that's the old closest black hole to Earth, or the second closest black hole to Earth now, is because they're actually giving off X-rays. Now, it's not the black hole itself, it's the material that the black hole is taking in. So the black hole gets greedy. If it's orbiting another star, it can drag gas off that. The gas spirals around the black hole in what we call an accretion disk, and it heats up because it's going so fast, and it starts to glow in things like X-rays, sometimes even radio emission. If you get very energetic systems like the supermassive black holes in the center of galaxies, you can also see like UV and optical from that accretion disk as well. So the majority of black holes we know about are in these X-ray binary star systems. And we know of about 100 or so of those things. And not all of them will either be black holes either. We think some of them are neutron stars. They're not quite massive enough to be a black hole. But unfortunately, that number doesn't match up with what models say for our population of the Milky Way. So if you sort of synthesize what you think a huge collection of stars, hundreds of billions of stars in the Milky Way would be like and what they do and how they'd spend their lives, how they'd end their lives, how many would be big enough to turn into a black hole, how many would be big enough to neutron star, white dwarf, etc., etc. You end up predicting that in a galaxy like the Milky Way of 100 billion stars, there should be about 1 billion black holes as well. So the question is whether the models are over-predicting the number of black holes, or we're just missing a huge population of black holes in the Milky Way, which could indeed be true. We've made some estimates before, given how many X-ray binaries we've been able to spot, thinking about, the distances between stars in these binary and triple systems, and which black holes, if they formed, wouldn't accrete matter, so you wouldn't know they're there. And we do get appreciable numbers, but nowhere near 1 billion. So it's a difficult one, but the fact that people have been able to find a black hole in what was originally thought to be a double star system has given people a little bit of hope. And this might be another avenue of research that people could focus on in order to try and reconcile these two big issues. And I'm just going to say this now because I know this question will come up in the comments, but no, 1 billion black holes would still not be enough invisible matter to explain how much dark matter we think is in galaxies. I knew someone would ask that question, so I'm jumping on it now. Next up, have we solved a currently unsolved mystery? So in my top 10 list of unsolved mysteries I posted last week, number 8 in that list was what is causing fast radio bursts. These incredibly short, of the order of millisecond bursts of radio waves coming from space, outside of our own galaxy, from all different directions we've detected these from, some of which have repeated, some of which haven't repeated. We've just seen them once and then we've never heard from them again. Usually when they repeat with no apparent pattern either. And so all the ones we've detected so far have come from outside our own galaxy. And we know that they must come from something that is incredibly small because the burst of energy is so short, but also that it must be incredibly energetic, because in that millisecond burst, the same amount of energy is released as is released by the sun in 80 years. And there has been so many hypotheses just flying around since these things were first detected back in 2007 or something, that were trying to explain, what's producing a fast radio burst. And no one had really agreed yet on what the most likely mechanism was. But on the 28th of April this year, 2020, 2 radio telescopes detected a burst of radio waves from a magnetar in our own Milky Way galaxy that's something like 30,000 light years away. And this burst of radio waves looked very similar to the FRBs, the fast radio bursts that we detect from outside our galaxy. So magnetars are essentially neutron stars, right? The leftover remnants of a supernova where the matter has been crushed down and down and down until all you're left with is neutrons as closely packed as they can go. Magnetars, though, are a special type of neutron star because they have a huge magnetic field, 1,000 times stronger than a normal neutron star does. And we don't really understand where this magnetic field comes from because nobody in astrophysics understands magnetic fields, especially at such high intensities, the kind of we just don't see here on Earth. But what we do see is the effects of this incredibly strong magnetic field. It actually distorts the shape of the star because sort of the magnetic field and gravity are sort of in constant competition with each other, and it's thought that these distortions lead to things such as star quakes, which can then give rise to these flare of X-rays or radio waves. So on April 27th, this magnetar had such a flare, possibly from a star quake, and that was detected in X-rays by, for example, the Swift telescope. And that wasn't anything particularly special. A lot of magnetars already do that. But the very next day is when that burst of radio waves was then also detected as well. That had a very similar signature to the fast radio burst that we detect from extragalactic sources. So these radio bursts were detected by the CHIME experiment in Canada that's been detecting, reams and reams of these fast radio bursts from outside our own Milky Way, and also a project called STARE-2, which is a radio antenna array that was specifically set up to search or listen for these fast radio bursts coming from the Milky Way itself, because people have been hypothesizing for a while that if they're happening in other galaxies, then eventually something should happen in the Milky Way too. Now, if you took the signal that both CHIME and STARE-2 have actually detected and you correct it for the differing distances, then yes, it would look very similar to the fast radio bursts we detect extragalactically. However, what they've not done yet is actually compare what's called the spectrum of light you receive in that radio burst. So when you take the light that you receive and split it into its component wavelengths and look at the trace, does that look very similar? So that's sort of the piece of information people are still waiting for. And if they find that they are incredibly similar, then that probably will be the smoking gun that says, yes, it's very likely that magnetars are responsible for these fast radio bursts. However, even if that does happen, it doesn't mean that magnetars are the only explanation for fast radio bursts. It could be that we need another hypothesis entirely to explain the ones that burst repeatedly. Or maybe the magnetars explain the ones that burst repeatedly but don't explain the ones that just have a single flare and then we don't hear from them again. So it's actually a mad scramble now to analyse all the data that's been collected. So this isn't a paper that's been published announcing this. This was what's called an astronomer's telegram, where people basically just put a shout out like, hey, we detected this thing from this part of the sky. And so that's all that's been announced so far, that this was detected, that it's a known location of a magnetar. Obviously, putting two and two together could mean that, yeah, okay, the very likely origin of fast radio burst is a magnetar, but we don't know that for sure yet. But it is a good step in the right direction. So I am very sorry to disappoint all of you that we're secretly hoping that it would be aliens. One day, maybe it'll turn out that the weird signals we're receiving from space are aliens.
But it is not this day.
That's it for this month's Night Sky News. As always, if you do any stargazing and you take any pictures, send them my way on either Twitter or Instagram. I always love to see them. But until next time, friends, stay home, stay safe, and happy stargazing. I feel like I should have like a cat or something to stroke in this fancy new office chair that I'm sat in, that I can spin in. Ooh. They also had a magnetometer, magnetometer. Really doesn't roll off the tongue, that word. Mr. Black Hole, please tell us why you had to hide away for so long. This camera that only records 10 minutes and so frustrating. Don't know where I got cut off on. But it's times like these you charge your battery again. It's times like these, time again. On the 28th of April, 2 radio telescopes, what am I, Southern? Ugh.